Let's solve some sums based upon the nature of roots of the equation. Let's take the first example. We have to find the nature of the roots of the following equation, right? We know now what is the procedure. We will find the discriminant. So, b square minus 4ac, right? So, we will find if this is greater than 0. We know that the roots are going to be real and distinct. If this is equal to 0, roots are going to be equal and real. And if this is less than 0, then this equation will have no solution. So let's calculate the discriminant of this. For that, we need to find a. What is a? Coefficient of x square, which is 4. What is b? Coefficient of x along with the sign. This you should remember always. And what is my c? C is 50. Okay, let me find the discriminant. Discriminant is equal to b square. What is my b? Minus 10 whole square minus 4 ac. What is my a? 4 and b is 50. C is 15. Okay. So d is equal to 100 minus 15 fours are 60, fours are 240. So I got the value of d as minus 140. So you have seen that your discriminant, that is b square minus 4ac, is less than 0. So what can you say about the roots of this quadratic equation? It has no solution or the roots are imaginary. This is how you comment upon the nature of the roots of the equation. Now, in second case, we have to find the value of q for which the equation has equal roots. Now, when our equation has equal roots, at that time our discriminant is equal to 0, right? That means my b square minus 4ac will be equal to 0. Fine. Let's take the equation and identify a. A is 3, b is minus q, and my c is 2. Since b square minus 4ac is equal to 0, that means minus q whole square minus 4 into a is 3 into c is 2. So this is equal to 0 because discriminant is equal to 0. Why? Because the equation has equal roots. So this becomes q square minus 24 equal to 0. So q square will be equal to 24. So q will be equal to under root of 24. So q will be equal to 6 fours are 24. 6 will remain there and we'll have plus minus under root of 6. So for two values of q, one is minus 2 root 6 and another is plus 2 root 6. This equation, if you substitute minus 2 root 6 in place of q here, then this equation will have equal roots. Or if you substitute q as 2 root 6, then also this equation will have equal roots. Fine. Let's go to the third part. Now here we have to find the value of k for which this equation will have real roots. Fine. Now, when do any equation has real roots? If d is greater than 0, then also the equation has real roots. And if d is equal to 0, then also the equation has real roots. Let's combine this. So when d is greater or equal to 0, then this equation will have real roots. That means b square minus 4ac, if it is greater than 0, then this equation has real roots. In fact, it has real roots. Using that, we have to find the value of this k. Let's identify a here. A is k. What is my b? B is 5, sorry. And what is my c? C is 1. right? Now let's substitute the values here. B square, that means 5 whole square, minus 4, A is K, into K into 1 is greater or equal to 0. It means 25 minus 4K is greater or equal to 0. That means 25 is greater or equal to 4K. 25 by 4 is greater or equal to K. Or you can even write that K is less or equal to 25 by 4. So all the values which are less than or equal to 25 by 4 will satisfy this equation. For those values, this equation will have real roots.